right, hi ladies and gentlemen. I wanted to take a moment to go through with you the 5.1 Day 2 Our Soda Contest's true activity. Because even though maybe we can't simulate it, I still think it's an important thing to walk you through. So Pepsi ran a promo contest for their 20-ounce bottles of soda. Some of the caps said, "Please try again," while others said, "You're a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." Mrs. Walker's stats class wonders if the company's claim is true. To find out, all 30 students in the class go to the store and each buys one 20-ounce bottle of the soda. 2 of the students get caps that say, "You're a winner." So, how many winners would you expect to get out of a class of 30, and is it guaranteed? So, when we think about this, we know that there's a 1 in 6 chance of someone getting a prize based upon the slogan of Pepsi. Well, if we take 1 out of 6 and multiply that by our 30 students, we would expect about 5 students to get 1 out of 6, or about 5 students to get a prize. And is it guaranteed? Definitely not, right? This is just approximation. There's definitely no guarantee that exactly 5 would happen. We can never make guarantees, really, in statistics ever. So the question says, does this result give convincing evidence that the company's 1 in 6 claim is inaccurate? We will perform a simulation to help answer this question. And then we will assume Pepsi is telling the truth. If they are telling the truth, what is the probability of getting 2 or fewer winners in a class of 30 purely by chance? And let's find out. So I know that we can't necessarily do this as a class because you're all virtual, and maybe I'll try simulating this with you via Zoom, but I do still want to take the opportunity to walk you through what this process looked like and how we would answer our question, even though we can't, do the simulation here in reference to this video I'm creating right now. So looking at question 2, what could we use to model a 1 out of 6 probability? Well, we have to think about something that has 6 sides to it, if you will, so that might give it away, that we could use a die, right, or a piece of dice. And then we could say 1 is the winner, because it's a 1 in 6 chance of winning, and numbers 2 through 6, are the losers. Right? So if you roll a 1, you win. If you get a 2 through 6, you lose. So roll your dice 30 times to imitate the process of the students in my stats class buying their sodas and how many of them won a prize. So what you would do to simulate this is we would continue rolling the dice 30 times and we would tally up how many times we get a 1 and we would write that answer there. So let's say we get 6 of them getting a prize. Then you're going to repeat steps 1 and 2 and how many won a prize this time. So now you do it again and you figure out, well, how many won a prize this time? And maybe this time I only get 3. Then question 5 says plot the number of the winners on the board. So this is where we would create like a dot plot, right, to represent our data. And so, for example, we could get something that looks like this. 6, 7, 8, 10, and so on and so forth. And then if I were plotting the numbers that I got, I would plot a number at 6, and then I would plot a number at 3, right? And we would eventually get this dot plot of all of our statistics written down. Now, to answer question 7, it says, what percent of the time did Mrs. Walker's stats class get 2 or fewer prizes just by chance? So to answer this question, we would be looking at how many dots are at 2 and less than 2, and we would divide that by the total number of dots to find our percentage. So it would be 2 or lower divided by total number of dots. And that is going to give us our percentage. From there, to answer question 8, does it seem plausible that the company is telling the truth by that the class just got but the class just got unlucky? So in other words, do we have convincing evidence that Pepsi is lying? This is where we're looking for, do we have something that is statistically significant? That is the question that says, do we have something that is unique that is happening because simply by chance we cannot replicate those same numbers? Or do we not have something that is statistically significant, meaning it is not unique because we are able to replicate the same information purely by chance through the simulation we just did? So the way question 8 would be answered is if we have something that is below or equal to 5%, we would say that it is statistically significant. In other words, we would answer this question to say yes, or we would say no if we get something greater than 5%, because that means it's not statistically significant. So I know we were not able to do the simulation ourselves, but on the back side of this worksheet is an example of something that was simulated and is walking through the same series and types of questions. So I strongly encourage you give these a try and then check your answers with my key that are posted on Canvas. And this will wrap up the 5.1 information. I know that there's a dolphin problem in the 5.1 lesson, and maybe that's something I might do via Zoom, and if I don't, then it's not something you have to worry about. All right, thank you so much. Have a great day.